In this question, we have an isotropic material which is stressed in the y and x directions. But there are rigid walls which prevent deformation in z direction. We know the relation between sigma y and sigma x. In part A, we would like to find if any stress develop in z direction. If a stress occur in z direction, we will find an equation for sigma z. In part B, we will determine the stiffness in the x direction. And finally, in part C, we will compare the stiffness with the Young's modulus. Let's start with the observations. Since there are rigid walls, we know that the material will not deform in the z direction. So, epsilon z will be 0. Let's start with part A. A stress will occur in the z direction because of the rigid walls. So let's find the equation for sigma z. Using generalized Hooke's law, we know that epsilon z is equal to 1 over e times sigma z minus Poisson's ratio times sigma x plus sigma y. And we know that sigma y is lambda times sigma z, sigma x. So we have epsilon z as and it is equal to 0. So we have sigma z is equal to Poisson's ratio times 1 plus lambda times sigma x. And this is the answer for part A. Let's move on to part B. We know that stiffness in the x direction is sigma x over epsilon x. We know sigma x, but we should find an equation for epsilon x too. Again, from generalized Hooke's law, epsilon x is 1 over e times sigma x minus Poisson's ratio times sigma y plus sigma z. And we know both sigma y and sigma z in terms of sigma x. So let's substitute them. Now, when we make some arrangements, we get Let's now substitute epsilon x to the stiffness formula. And finally, we get E over 1 minus Poisson's ratio times lambda minus Poisson's ratio squared times 1 plus lambda. Let's move on to part C then. We will compare E prime with E. First, assume that Poisson's ratio is equal to 0.3. Then, for lambda is equal to -1, E prime is equal to E over 1.3. And it gives us 0.77 E. For lambda is equal to 0, E prime is equal to E over 0.91, and it is 1.099 E. Finally, for lambda is equal to 1, E prime is equal to E over 0.52, and it is 1.92 E. As a conclusion, we can say that value of the stiffness for the x direction changes depending on lambda. When we change the value of lambda, we got a different value for E prime.